Imagine enjoying juicy burgers and steaks without the ethical and environmental baggage of traditional livestock farming. This is the promise of lab-grown meat, also known as cultured meat. Unlike conventional meat, which requires raising and slaughtering animals, lab-grown meat is produced by cultivating animal cells in a controlled environment. This technology involves growing animal cells in a lab, creating meat products identical to those from farm-raised animals. The process starts with a small sample of animal cells, which are then placed in a nutrient-rich culture medium. These cells multiply and develop into muscle tissue, which is the main component of meat. The result is a product that looks, cooks, and tastes like traditional meat, but without the need for animal farming. Lab-grown meat offers a solution to global challenges like deforestation, greenhouse gas emissions, and water pollution. Traditional livestock farming is a major contributor to these issues, but lab-grown meat has the potential to mitigate them significantly. By eliminating the need to raise and slaughter animals, lab-grown meat can significantly reduce animal suffering. This not only addresses ethical concerns but also aligns with the growing demand for cruelty-free food options. Early studies suggest it could require less land, water, and energy compared to conventional farming. This means that lab-grown meat could be produced more sustainably with a smaller environmental footprint. It also offers a way to produce meat with a lower risk of contamination, improving food safety. Since the production process is highly controlled, there is less chance of harmful bacteria and pathogens entering the food supply. While still in its early stages, lab-grown meat represents an exciting frontier in the future of food. As technology advances and production scales up, it could become a viable and sustainable alternative to traditional meat, helping to feed a growing global population. One pressing question about lab-grown meat is its energy consumption. Producing meat in a lab is energy-intensive, relying on specialized equipment and controlled environments. Currently, much of this energy comes from fossil fuels, which contribute to greenhouse gas emissions. To realize the environmental benefits, transitioning to renewable energy sources is crucial. Solar, wind, and other renewables must power the bioreactors and facilities involved in production. Optimizing energy efficiency is also paramount. Researchers are exploring ways to reduce energy consumption during cell cultivation and other stages. Addressing the energy demands of lab-grown meat is essential for its sustainability. Lab-grown meat production requires significant resources, particularly water and nutrients. These resources are fundamental to the entire process, ensuring that the cultivated meat is both safe and nutritious for consumption. Water is essential for cleaning, sterilization, and as a component of the cell growth media. Without adequate water, maintaining the sterile conditions necessary for cell growth would be impossible, leading to potential contamination and failure of the cultivation process. Nutrients like sugars and amino acids are crucial for cultivating healthy animal cells. These nutrients provide the energy and building blocks required for cells to grow, divide, and develop into muscle tissue that mimics traditional meat. Efficient water usage and recycling systems are essential to minimize the water footprint. Implementing advanced water recycling technologies can significantly reduce the overall water consumption, making the production process more sustainable and environmentally friendly. Many growth media components are derived from plant-based sources, but their sustainability depends on production methods. The choice of plants and the methods used to extract these components can greatly influence the environmental impact of the growth media. Scientists are exploring alternative sources like algae and insect protein for growth media. These alternatives not only offer a sustainable option but also have the potential to reduce costs and improve the efficiency of the growth media. Developing cost-effective and environmentally friendly growth media is key for scaling up production. As the demand for lab-grown meat increases, finding ways to produce growth media sustainably and affordably will be crucial for the industry's success. Addressing these resource demands requires a multifaceted approach. This includes optimizing resource use, exploring alternative materials, and continuously improving production methods to ensure that lab-grown meat can be produced sustainably and at scale. Lab-grown meat production generates waste products like unused growth media and cell culture waste. Managing these waste streams responsibly is crucial for sustainability. One approach involves treating and reusing waste within the production process. Some companies are exploring methods to sterilize and recycle used growth media. Utilizing cell culture waste as fertilizer or animal feed can contribute to a circular production system. Innovative waste management strategies are being implemented by leading companies. For example, anaerobic digestion can break down organic waste, generating biogas for energy. Embracing a circular economy model can minimize the environmental footprint. Traditional livestock farming requires vast tracts of land, contributing to deforestation and habitat loss. Lab-grown meat offers a solution by requiring significantly less land for production. Instead of sprawling pastures, it's cultivated in vertically stacked bioreactors within controlled facilities. These facilities have a much smaller land footprint compared to traditional farms. This reduced land requirement presents several environmental benefits like preserving forests and ecosystems. Shifting meat production away from land-intensive practices can reduce deforestation rates. Concentrating production in controlled environments minimizes pollution risks. The transition to lab-grown meat could alleviate pressures on land and water resources. While lab-grown meat offers innovative solutions to some of the most pressing environmental challenges we face today, it's crucial to approach it with a balanced and well-informed perspective. Despite its potential benefits, such as reducing the need for traditional livestock farming, lab-grown meat production does come with its own set of environmental costs that cannot be ignored. Energy consumption remains a significant concern in the production process, especially if the production facilities are heavily reliant on fossil fuels, which contribute to greenhouse gas emissions. Transitioning to renewable energy sources and improving energy efficiency are essential steps to mitigate these impacts. Water usage in lab-grown meat production, though generally lower than traditional farming, still requires careful and sustainable management practices. Additionally, sourcing raw materials for the growth media can contribute to deforestation and habitat loss if not managed sustainably. Researching and developing alternative, eco-friendly sources for growth media is an ongoing challenge that scientists and industry leaders are actively working to address. Balancing the benefits of lab-grown meat with its environmental costs requires a holistic and comprehensive approach. Life cycle assessments can provide valuable insights into the overall sustainability of lab-grown meat, helping to identify areas for improvement and innovation. To realize the environmental potential of lab-grown meat, continuous optimization is essential. This includes minimizing energy consumption, reducing water usage, and implementing robust waste management strategies. Advances in bioreactor design and growth media formulations are improving efficiency. Some companies are developing closed-loop systems that recycle water and nutrients. Collaboration between academia, industry, and policymakers is crucial for innovation. Transparency throughout the supply chain is essential for building consumer trust. Clear labeling and environmental impact assessments can help consumers make informed choices. The goal is to develop a lab-grown meat industry that is both environmentally sustainable and ethically sound. As lab-grown meat moves to supermarket shelves, consumers will shape its future. Educating the public about its benefits and challenges is crucial for informed decision-making. Consumers can advocate for sustainable practices by supporting responsible companies. Choosing products with clear labeling and certifications can encourage sustainable practices. Engaging in conversations about the future of food is essential. Discussing ethical implications and environmental considerations can foster informed public discourse. By staying informed and supporting sustainable practices, consumers can help shape a healthier planet. Lab-grown meat presents a solution to environmental and ethical challenges of conventional farming. Shifting meat production away from resource-intensive practices can reduce our food's environmental footprint. However, lab-grown meat is not a silver bullet solution. It comes with challenges like energy consumption and resource management. The future of lab-grown meat hinges on addressing these challenges effectively. This requires continuous optimization, technological advancements, and responsible regulation. Informed consumer choices are also crucial. By working collaboratively and committing to sustainability, we can create a more ethical food system for future generations. So that wraps up this video about lab-grown meats. Thank you for joining us today. Now pick another video from above and let's keep brain bending together.